Hello and welcome to the July 2025 monthly spotlight from Manitowoc Ice. My name is Josh Klepadlo. I'm a technical trainer here at the Factory Training Center. And today we are going to take an in-depth look at the water system on the Neo Undercounter Machine with onboard water filtration. Before we get started talking about the machine, I just want to let everybody know that our dates for our 2025 and 2026 Factory Level 3 training season have been updated. There is a link on the screen there, as well as a QR code that you can scan, and that'll bring you to the site where you can sign up for the class. Also, just like every other month, at the end of the presentation, there will be a QR code to take a little quiz, 10-question quiz, not too hard. And for every 25 entries of people that take the quiz, we draw one name out of the bag to win a little prize pack of some Manitowoc items. So let's get into the machine. We're going to go over, like I said, the water system on this machine. We're going to talk about all of the components, from the actual components that the water is flowing through to the components that control when the water flows and where it flows. We're going to take a step-by-step walk through both modes that the machine runs in, ice making mode as well as clean mode. We're going to discuss some changes that we made in the clean mode, and then we're also going to go over to the hands-on machine that I have here in the studio, and we're going to take a look at all these components, where they're located in the machine, and talk a little bit on how to properly diagnose them. We categorize the machine components into two categories. We have the flow components. These are the components that the water actually travels through. Those consist of the water inlet valve, the water filter head, the water filter, the water pump, and the dump valve. And then we have what we call the control components. These are the components that control when and where the water flows. We'll go ahead and take a look at the water system flow chart. So you can see the water comes in through the water inlet connection. It then travels through the water inlet valve. From there, it travels over to the water filter head. Now, it's important to note on this new machine with the integrated water filtration that that water filter head is self-bypassing if the filter is removed. So that's why we have a little jumper there around the water filter. If it is in bypass mode and the water filter is not in there, obviously the water can't travel through a filter that's not there. So from the water filter head, it would travel normally through the water filter and then over to the water trough. From the water trough, it has two places it can go depending on what the control components are telling the machine to do. If we're telling it to make ice, the water is going to travel down to that water pump, get pumped up to the distribution tube, fall across the evaporator. Some of it's going to freeze into ice, some of it's going to return back to the trough and keep completing that cycle. If the machine is in a dump mode, it is going to energize the dump valve, and it's a gravity drain, so it does not need to run through that pump in order for water to flow through the dump valve. So now that we've covered all of the components in the water system and what order the water flows through them, we're going to take a look at the order of operations so we know when those components are energized, how long they should be energized for, and what kind of inputs the control board is looking for to decide what it's going to energize. In my opinion, this is the most important thing to know when you're working on ice machines. You could be a master of the refrigeration cycle, electrical theory, diagnostics, whatever. But if you do not know how this machine is designed to move throughout the sequence of operations, you could be in front of it and it could be doing whatever it's doing, and you have no clue if what it's doing is right or wrong. All you know is we're not getting ice in the bin. So this is, in my opinion, the most important thing to know. So to start, whether it's coming out of a bin full situation and the damper just closed, or if you just walked up to it and pressed the button to turn it on for the day, we're always going to energize the dump valve for 20 seconds. That's going to get any water out of the pan. We don't know how long that water's been sitting there. It's always just better to start with clean water because ice is food. After those 20 seconds, we go into refrigeration startup. There are no water components energized at this time. We're just simply starting up refrigeration. We're not going to cover too much into that today because, again, we're just doing a water video. Next, we go into the freeze sequence, starting with our pre-chill. If it's the first batch of ice in a sequence, we're going to pre-chill for 2 minutes, 120 seconds. Any batches after the preliminary freeze, we are going to only do for 60 seconds a pre-chill. During pre-chill, water pump is off, water inlet valve is on. Dump valve is off at this point. What we're looking for is the harvest float, the low level float, should rise and open. Now we're going to go into freeze. We now have turned our water pump on and our water inlet valve is still on. What we're doing is we've now ran water up through the pump, down across the evaporator, takes a little bit of water out of that trough, so we keep filling with water until we now see the ice thickness float switch open. That would be our high level float. That way we know we have the proper amount of water in the closed loop system to make a batch of ice. Now, it's important to note on these new machines with firmware 2.58 with the thermistor, when the water temperature in that trough reaches 34 degrees, the pump will de-energize for 25 seconds. When the pump restarts, the water inlet valve also energizes for another 7 seconds. This is to reduce the chance of slushing that water, because you can't pump slush. We want to reduce the chance of slushing that water, keeping it liquid so that we can make a batch of ice. We're going to stay in freeze until we see that harvest float, or the low level float, drop and close for 10 seconds consecutively. Once we've done that, we know we've used all the water and we can go into harvest. So now that we've used all that water during the freeze cycle and turned it into beautiful ice, we are ready to drop it down into the bin. Once we see that harvest float close for 10 seconds, we're going to initiate the harvest sequence. During the harvest sequence, originally what everyone's used to seeing is water running down that drain as soon as it goes into harvest every single cycle. With this onboard water filtration machine, we changed the programming a little bit, so now we're only dumping water every 4th cycle. While we're still in harvest, we're going to keep the water pump off, the water inlet valve off, and the dump valve off. Again, the dump valve will energize every 4th cycle. But after 3.5 minutes of it being in harvest, generally they won't be in harvest that long, but if it does, we turn on the water inlet valve, we turn on the dump valve, and we turn on the water pump to bring in a little bit of fresh water with some more heat, run it across the evaporator plate, and help it drop that ice off into the bin. What we're looking for now is the bin switch activation. When that goes from a closed state to an open state back to a closed state, we'll loop back up to sequence of operation number 3, pre-chill. And again, if it's the 2nd cycle, it's only going to pre-chill for 60 seconds. And then it's going to go back through until that curtain is held open by a sheet of ice. If the curtain's held open, the machine goes into bin full. When the curtain recloses, it goes into a 3-minute delay. And when we go back up into the cycle number 1. Talk about now what happens in clean mode. When you press the button for clean, we're going to energize the dump valve for 45 seconds, look for both float switches to go to the closed downward position, meaning that there's no water in the water trough to start. Then we're going to fill water for a maximum time of 1 minute until the high level float is satisfied. The ice thickness float is satisfied or goes open. Consult with your installation, operation, and maintenance manual on the amount of cleaner to run into this machine and the time of when to put it in. Next, we're going to go into a circulation clean mode for 10 minutes. At this point, the only thing that's energized is going to be that water pump. We're just circulating cleaner or sanitizer through this machine for 10 minutes. After that, we're going to dump that water or chemical down the drain for 45 more seconds, looking for both float switches to close. If either one of the float switches stay open during any of the dump cycles, a clogged drain fault will be activated on the machine and will stop cleaning until you correct whatever's wrong. It's then going to fill water again until the high level float goes open. It's going to rinse it off for 90 seconds, 1.5 minutes, and then it's going to dump it down the drain for 45 seconds. It's going to do this flush cycle after the circulation 6 times until we get all the way down here to number 19, which would be the final dump cycle for the cleaning cycle that you're in. Again, consult your installation, operation, and maintenance manual or your technician's handbook for in-depth step-by-step guide on cleaning these machines. We're not going super in-depth on that today, but this does tie into our next slide of the clogged drain fault. The clogged drain fault was a new fault that was added during the cleaning cycle only to prevent ice from being possibly made with any leftover sanitizer or ice machine cleaner that could possibly have been in the pan still after a cleaning cycle from potentially, like it says, a clogged drain or something preventing the cleaner from getting out of the machine. This fault will only set during a clean mode. It sets if the board does not see both floats drop back down to the closed downward position after the 45 seconds of the dump cycle during any of the 7 dumps that happen during a cleaning cycle. Again, this is just done to ensure that we don't accidentally make some ice with some cleaner or some sanitizer. Remember, a clogged drain fault will only activate during a cleaning cycle. And you will know that it's a clogged drain fault and not just that the unit is in a cleaning pause mode, because the pause mode, the cleaning light will be flashing as well as the on-off light will be flashing. If you're in a fault for the drain mode, you will only have a clean light flashing. The on-off button will be off. So let's take a look at the flow chart here to figure out what could be our root cause for this fault. First thing you're going to do, again, like I said, make sure you're actually in a clean fault, not in a cleaning pause. Then what we're going to do, we're going to take a look inside that water trough. Is there water in the trough? No? Okay. Simple. Open up your control board cabinet, take a look at which float switch is telling the board, I'm still full of water. Which one is still open? And then diagnose from there. If you look in and you do have water in the pan, you're going to check, is my drain line free from blockages and obstructions? It's in the name, right? Clogged drain. If it is not free of obstructions, repair the outlet drain and reinitiate the cleaning cycle. If it is clear for blockages, you're going to perform a control board output test and consult your technician's handbook on how to do that. I'm not going to go into that right now, but you will then figure out which one of the water components that we talked about earlier are not functioning properly to get that water out of the pan. Now we're going to go into a little bit of component diagnostics, and this is one of my favorite parts of working on ice machines, is actually the hunt of figuring out what is going on. So we'll start with the ice thickness float switch. This is also known as the high level float. This is the one that determines we have enough water in the machine to make the appropriate bridge of ice that we're looking for. It is identified, normally closed, in the down position, like I said a couple times throughout this video. It's the indication LED number 11 on the board will be lit when the float is in the up or open position. Now, these float switches can be accessed without having to take anything off. You can get in from the front of the machine through the door and access these for testing. I'll show you that in a little bit. The harvest float switch, also known as the low level float, is another normally closed in the down position switch, and that is indicated by number 10 on the board when it is in the open position, the up position. So to diagnose these floats using the control board, I can't stress this enough. Remember this, when they're down, the light should be off. When they're up and open, the light turns on. If the control board light does not respond to the movement of the switches, you're going to follow these little steps. You're going to disconnect the power to the machine, pull the wire through the bulkhead connector, and I'm going to go over to the machine and show you guys all of this, and disconnect. You're going to check for ohms resistance on the float switch. When it's down, you should have 0 ohms of resistance. When it's up, you should have infinite ohms of resistance, or OL, on your meter. We're over here at our example unit. You don't normally have to take the bin off in order to access these float switches, but it's a little bit easier to show you guys what's going on. So, got the bin off, obviously. We have our water level float switch and our harvest initiation float switch. To test these, if you have the bin on, come through the front door, or take the top off if you have that ability. I know due to some installation types you're not able to actually get that top off and get in there, but you should always be able to get them through the front. So, seen, I just take this grommet out, you gently fish these 2 wires through here. Now this harness here goes down to your control board. We're going to unplug the float switch from the harness. Now we have this isolated. You can take your meter, have it set to continuity. I'm not going to use the beeping function today for the sake of your ears during the video, but go ahead and test your meter before you test the float switch. Now, you can get these in there. Okay, so you see right now, we have good continuity through the switch. That's proper because our switch is down, there's no water in our trough. You can reach your finger in here, pick up on the float, and the switch should open. Drop it down, should close. So this switch is functioning fine. If I found that I had an issue getting continuity back to my board, at this point, I would go ahead and check the continuity through my harness back to the connector. Let's see what we got. Then to hook these back up, just hook them back up. They are not polarized or indexed in any way except for the shape of the connector. Fish these back through the bulkhead. Push your excess wire. Go ahead and put your grommet back in there. Fish the wire in. Don't pull it super tight. Leave a little slack, a little drip loop. If you needed to test the harvest switch, you could do the same thing. Just remove this from the bulkhead, pull it through, disconnect, check your continuity. They do work the same way, both switches. They are not the same part number. The water inlet valve. This valve is normally closed. The line voltage for the valve is sent through a relay that's built into the control board, and it is indicated by LED number 9 on the board when it should be sending voltage out to that component. The water pump, this is another component that is the line voltage is controlled by the control board, and this uses LED indicator number 1 on the control board to tell you that it should be outputting voltage to that component. Dump valve, just like the water inlet valve, normally closed. Line voltage is controlled by the control board. Indication LED number 3 on the board will be lit when it is sending or should be sending voltage out to that valve. And again, this is a gravity-fed valve. You will not need the water pump energized to run water through this valve. So just a little tips and tricks here with when you're trying to diagnose these using these LEDs. It's important to note that just because the LED is lit, it does not guarantee that the board is outputting voltage to that component. You do not want to rely on the boards when diagnosing components. You always want to confirm for voltage at the connector of the component that you're testing with a meter. And then you always want to confirm your continuity through the harness and with the float switches back to the board. Taking a look at our example unit, I have the bin already taken off, which we have other videos that show how to remove the bin. You do not have to take this machine out from its installation location in order to take the bin off on our machine. We're going to go through the water components real quick and show you where they're located in the machine. Back here in the corner, we have the water inlet valve. From there, like we said, we flow up to the filter head. We have a filter cartridge installed. From there, it goes up here to the water pan or water trough. We have our 2 float switches that we already discussed in a previous section. Down here we have our water pump, and right here we have our dump valve. That's all the components inside of this machine's water system. So that will conclude today's spotlight on the water system of the Neo Undercounter Neo. Again, our 2025-2026 Factory School Level 3 training. All the dates are up and accurate on the website. I have a link at the bottom of the screen, as well as a QR code that you can scan that'll take you to the sign up. And as always, what everyone is really waiting for, the post-presentation quiz. If you enter that link or use that QR code, you can take a little 10-question quiz about what we covered today. And what we're going to do is, for every 25 entries that happen, we will draw 1 name randomly to win a prize, and then I will contact you through email to get that sent out to you. If you work for Manitowoc Ice, you are not eligible to win any of this stuff. I'm sorry. The quiz, I'm going to put it up now when the video is posted, and the entries, I will take a look at entries for the next 1 week, 7 days, and that'll make our pool. So I'll leave that on the screen for a little bit for you guys to take a look at. And thank you for watching. Remember to like and subscribe for more content, and comment below.